students, I just want to congratulate you for accomplishing your lesson 1. You did great and I hope that you keep yourselves excited and eager to learn new things. Just stay on track and remember that we are all in this together. Don't hesitate to ask me your questions for I am very willing to help you guys. Be prepared and let's get started. Let us know. Here are the terminologies, theorems, and ideas you will encounter in this lesson. Grab your paper and pen to write the important notes. You may pause the video from time to time for more convenient lecture writing. Let's get started! The absolute value of a number. When we talk about the absolute value of a number, it is the number or the unit of intervals of a number from the point of origin. The distance between two numbers is the number of units between them. Absolute value asks how far, not in what direction, a number from 0. Or in other words, the absolute value of a number is its positive value. Addition of integers. To get the sum of two integers, always remember these two rules. First, if we are adding integers with the same signs, add their absolute values and affix their common sign. Second, if we are adding integers with different signs, subtract their absolute values, then affix the sign of the integer with a greater absolute value. Subtraction of integers. In subtracting integers, change the sign of the subtrahend, then proceed to addition. In other words, after changing the sign of the subtrahend, the rules in adding integers must be observed. Multiplication and division of integers. In solving for the product or quotient of integers, we follow the same rules in multiplication and division of whole numbers. But this time, we determine the sign of the product or the quotient. If we are multiplying integers with the same signs, the sign of the product is always positive. If we multiply integers with different signs, the sign of the product is always negative. The same way, if we are dividing integers with the same signs, the sign of the quotient is always positive. And if we divide integers with different signs, the sign of the quotient is always negative. I will do it. In this part of the video, I will do it for you. All you have to do is to watch and listen carefully. Avoid any distraction around you. You may watch this part of the video multiple times if needed. Let's go! Let us start this portion by finding the absolute value of a given number. The absolute value of a number is said to be the distance from the given number to the point of origin or 0. Let us start with number 1. It is read as the absolute value of positive 2. Positive 2 is here, so we're going to count the number of units to the point of origin. So we have 1, 2 units to the point of origin. The absolute value of positive 2 is positive 2. How about the absolute value of negative 2? Negative 2 is here, so we count the number of units to the point of origin. So we have 1, 2 units. Therefore, the absolute value of negative 2 is also positive 2. Next, we have the absolute value of positive 10. Here is positive 10. We count the number of units to the point of origin. So we have 10 units. The absolute value of positive 10 is also positive 10. The absolute value of negative 10. Negative 10 is here. So again, count the number of units to the point of origin. And as you can see, we also have positive 10. The absolute value of negative 10 is also positive 10. Let us apply the concept of absolute value in finding two numbers 3 units away from the given number. Let's have number 1, which is 3. Positive 3 is here, so we're going to count 3 units to the right of positive 3. So we'll get 6. And of course, 3 units to the left of 3. 1, 2, 3. So we have 0. For number 2, we have negative 1. Negative 1 is here, so we count 3 units to the right of negative 1. So we have positive 2. And 3 units to the left of negative 1. 1, 2, 3. So we have negative 4. Addition of integers. So we are now going to apply the rules in adding integers. Let's have number 1, positive 4 plus positive 5. And as you can see, they are of the same signs. They are both positive. So using the rule, we're going to add their absolute values. The absolute value of 4 and absolute value of 5 has a sum of, that's correct, it's 9. And we are going to adapt their common sign, which is positive. Let us have number 2, negative 4 plus negative 5. Again, they are of the same signs. So we're going to add their absolute values. 4 plus 5 will be 9. And we're going to adapt their common sign, which is negative. Very good. Now let us have number 3. We have positive 3 plus negative 7. They are of different signs. So the rule says we are going to subtract their absolute values. So 7 minus 3 will give us very good, it's 4. And we're going to adapt the sign of the integer with the greater absolute value, and that is negative 7. So it will be negative 4. For the last item, we have negative 3 plus positive 7. And as you can see, they have different signs. So again, we're going to subtract their absolute values. 7 minus 3 is again 4. But what will be the sign of the sum? What do you think? Alright, it's positive because positive 7 has greater absolute value. Very good. Subtraction of integers. In subtracting integers, we have to change the sign of the subtrahend, then proceed to addition. Let's have number 1. Positive 2 minus positive 7. First, we have to copy the minuend, which is positive 2. The next step is to change the subtraction symbol to addition symbol and change the sign of the subtrahend. From positive 7, it will become negative 7. We are now going to apply the rules in adding integers. They are of different signs, so we subtract their absolute values. 7 minus 2 will give us 5, and we will affix the sign of the integer with a greater absolute value, which is negative. Let us have number 2, negative 2 minus negative 7. So again, we copy the minuend. Then change the subtraction symbol to addition symbol and change the sign of the subtrahend. As you can see, they are of different signs again. So we subtract their absolute values. And it will also give us 5. But 7 here has greater absolute value, so we adapt its sign. Number 3, positive 2 minus negative 7. Copy the minuend. Change the subtraction symbol to addition symbol. Then change the sign of the subtrahend. As you can see, they are of the same signs. So we add their absolute values. 2 plus 7 will give us 9 and adapt their common sign, which is positive. For the last item, we have negative 2 minus positive 7. Copy the minuend. Then, change the subtraction symbol to addition symbol and change the sign of the subtrahend. They are of the same signs. So we add their absolute values. 2 plus 7 is 9. And their common sign is negative. For problems involving combination of addition and subtraction, I suggest this process. Let's have number 1, positive 38 plus negative 15 minus negative 6. I want you to focus on the first two integers. Positive 38 plus negative 15. They are of different signs, so we subtract their absolute values. 38 minus 15 will give us 23, and we will adapt the sign of the integer with greater absolute value, which is 38. So it will be positive 23. Then we will copy the remaining parts of the problem, minus negative 6. It is subtraction. So we follow the rule in subtracting integers, positive 23, or copy the minuend, change the subtraction symbol to addition symbol, and change the sign of the subtrahend. Then as you can see, we have positive 23 plus positive 6. They are of the same sign. So we add their absolute values, and it will give us 29 and affix their common sign. For the next problem, we have positive 71 plus negative 81 plus negative 26 minus negative 4. Again, focus on the first two integers. We have positive 71 plus negative 81. They are of different signs, so we subtract their absolute values. 81 minus 71 is 10. 81 has greater absolute value, so we adapt negative. Then we will copy the remaining parts of the problem. Plus negative 26 minus negative 4. Then we focus again on the first two integers. Negative 10 plus negative 26. And as you can see, they are of the same signs. So we add their absolute values. 10 plus 26 is 36, and we adapt their common sign. Then change the subtraction symbol to addition symbol. Change the sign of the subtrahend. And as you can see, we have negative 36 plus positive 4. Again, they are of different signs. So we subtract their absolute values. 36 minus 4 is... Very good, that's correct. It's 32. And we adopt the sign of the integer with greater absolute value. And that will be negative. Multiplication of integers. Multiplying integers is just like multiplying whole numbers. But this time, we're going to determine the sign of the product. Number 1, we have positive 4 times positive 3. What is 4 times 3? Okay, that's correct. It's 12. But since they are of the same signs, the product will be positive. The same as here in number 2. We have negative 4 times negative 3. 4 times 3 is again 12. And since they have the same signs, the product is positive. For number 3, we have positive 4 times negative 3. Again, 4 times 3 is 12. But since the factors have different signs, the sign of the product will be negative. The same as here, number 4, we have negative 4 times positive 3. 4 times 3 is 12, and the factors have different signs. So the sign of the product will be, very good, it's negative. The same concept is applied in division of integers. If we are dividing integers with the same signs, then the quotient is positive. If not, the quotient is negative. Let's have number 1. Positive 12 divided by positive 3. 12 divided by 3 is? That's correct, it's 4. They are of the same signs. So the quotient is positive. Number 2, negative 12 divided by negative 3. 12 divided by 3 is 4. And they have the same signs. So the quotient is also positive. For number 3, we have positive 12 divided by negative 3. Again, 12 divided by 3 is 4, but this time, they are of different signs. So it means that the quotient is negative. As well as here, number 4, negative 12 divided by positive 3 is negative 4. Let us have problems involving combination of multiplication and division. For number 1, I would like to start with positive 160 divided by negative 8. 160 divided by 8 is 20. They are of different signs, so the quotient is negative. Then copy the remaining parts of the problem. Then after that, I will focus again on the first two integers. We have negative 20 times positive 4. What is 20 times 4? That's correct. It's 80. But since they are of different signs, the product is negative. So we have negative 80 times negative 1. What is negative 80 times negative 1? It's positive 80. Very good, because they are of the same signs. For number 2, we have negative 45 divided by negative 9 times negative 6. As you can see, we have here a corner bracket. So it means we have to do it first. Okay? So we have negative 45 divided by negative 9. What is 45 divided by 9? That's correct, it's 5. But since they have the same signs, the quotient will be positive. Then we copy the remaining part of the problem. So we now have positive 5 times negative 6. What is 5 times 6? That's correct, it's 30. And since they are of different signs, the product will be negative. And that's it for our lesson for this week. I am Sir Rodel, your mathematics teacher, reminding you to make use of your time wisely. Accomplish what you can do today and do not hang it for tomorrow or for the next days to come. Have a great day, everyone. Bye.